Is trust the new world currency? What do you think? More and more organizations are interested in zero trust security. We're going to discuss in this how this is a security plan, how it's advancing, and so on. My name is Darlin. I'm chairman of two great groups in the BCS, North London and Central London branches. And more news is that I'm now also chair of South London branch. So, oh my God, 3/4 of the apple is going to be reaching out for information on great webinars like this one. Well, my name is Darlin, but we also have my great friend and colleague, David Grundy, the secretary of Central London branch, to support us in a technical role to make sure this all flows smoothly. But of course, a key component is you. So make sure that you, I'm sure you've read the blurb on this, but make sure that you have information, questions, and make the most of this webinar. Really want you to benefit from this. We will be recording it. That's David's role. And as far as he's concerned, he's getting to be a past master of this, isn't he? Well, we have a past master of the subject presenting to us, and that is Ulf Mattsson, who is very much a friend of ours and a great fan of our branches. So I want you to join me in welcoming Ulf. Please give him a virtual hand clap to welcome him. And as far as Ulf's concerned, he's all set, all poised in his home office, which is in Connecticut in the USA. So this webinar is brought to you by the wonders of modern technology and communications. Now, I was talking with some people today, some senior level people, about the sentence in the blurb, if you've seen it. We will discuss more on zero trust and the relation of this to quantum computing, homomorphic computing, differential privacy, and Web 3.0. Well, if those are topics of interest to you, that's great. Do listen, learn, and then ask some questions about it. And we'll see if we can persuade Ulf to talk about those topics on this or a later occasion too. Enough said, let's get going. Please sit comfortably. And Ulf, I'm going to hand over to you. Please say a few words about yourself and then tell us more about zero trust strategy. And why can we trust you? Over to you, Ulf Mattsson.
Thank you. I think the main theme here is that you can never trust. And in security, we usually say trust but verify. And that is no longer a strategy. You need to turn it around. You need to say, first we verify before we trust. And my background is in computers, security, data security, privacy. So I worked at IBM for many years. I started a company focusing on data security. And 10 years ago, I started to work with the founder of Zero Trust. His name is John Kindervag. At the time, he worked at Forrester. And he asked the question, why is security not working? And he came up with Zero Trust. And he said, we cannot let people in into our network, accessing our resources. It cannot be a gateway requirement, a static policy, and then we just let them in. So Jan Kinderwag said it needs to be dynamic. We need to constantly, continuously look what the user is trying to access. And he invented the term zero trust. So that was 10 years ago. People didn't know what he was talking about at the time. And now everyone is talking about that. Even the president of United States. I think it's a wonderful strategy. You actually need to have, what is a strategy for zero trust? Briefly, it is a way to question every request. So when a user is doing a request, you look at the context and see, should the user at this time have this access? So I love this. And whenever you have a question, just give it to me and I will see if I can answer it. So I'm thinking that we will look at basically 6 different topics. Sometimes people ask me, what is zero trust and what is zero knowledge? So I will talk a little bit about that because they are not related. They are completely different concepts. And of course, we will then talk about a little bit about breaches and data leaks. And talk about why are we doing this? Why are we concerned? And we talk a little bit about data protection, data security, data privacy, granular data field protection. And number 4 here is many organizations are asking about analytics. They don't want to do analytics in the old way. They want to protect their sensitive data, and they want to do it in the cloud more and more. So we'll talk a little bit about that. And then I usually get the question, should I use a data warehouse or a data lake? It's very black and white. A data warehouse, you have data that you have analyzed. You know what type of data you have. But on the contrary, in a data lake, you don't know anything. So typically in a data lake, you just shovel in data fast and furious. You don't know what you have. You don't know if it's sensitive data. You don't know if you need to comply to regulations on that data. So a data lake can be very, very dangerous. But it's a fast way to gather data and just shuffle it in. In a data warehouse, you have structured data. You have organized your data into different tables and columns. You know what you have. You know if it's sensitive data. You know what data need to be compliant to regulations. So we'll talk a little bit about that. And we talk a little bit more about different things at the bottom here. So what is zero knowledge proof? And what is zero trust architecture? So zero trust architecture is something that John Kinderwag at Forrester invented 10 years ago, about 10 years ago. And more recently, different organizations in US where I live started to define what is zero trust. So the government defined what is zero trust maturity. How do I know that I actually have zero trust? So we talked a little bit about that. So the government agency in US, CISA, C-I-S-A, defined a zero trust maturity model. And I will touch briefly on that. And then NIST in US, National Institute for Security and Technology, defined the zero trust architecture, where they said, this is what we mean by a zero trust architecture. So we talked a little bit about that. Let's get zero trust proofs out of the way first, because zero trust is completely different. So what is zero knowledge proofs? It's simply that I prove that I have a secret. For example, I can open the door. I don't tell you what the secret is. I don't tell you what the code, the PIN code is, but I can prove to you that I can open the door, and you can then trust me that, okay, I know a secret here. So that is basically zero knowledge proofs. And where is this used? It's typically used in blockchain, smart contracts, where you need to prove that you have something, you have a secret, but you don't want to give away the secret. So, okay, so let's forget about zero knowledge proofs. It's just a network protocol. What about zero trust architecture? On the top left, we have the starting point. That's a user that want to access something, access resources, access data. And in the middle, you have a policy. And the policy have something usually called a context. What is a context? It's a policy that is asking, okay, where's the user coming from? What time of day is it? And what is the user trying to access? And on the right-hand side, the interesting part of zero trust architecture is that you can apply it across your different environments, across hybrid cloud, where you have a combination of different clouds, on-prem, and multi-cloud, of course. Organizations are using more and more a combination of different cloud providers. And then we move down. On the right-hand side, we have data protection. You have different type of encryption, homomorphic and more. You have different type of noise or protection of data, like k-anonymity and other models that are actually adding noise to your data. And at the bottom, you have the more modern ways to replace data and replace identifiers with tokens that are random and very secure, very fast. If you go a little bit left, you have the whole concept of granular data feed protection. So use that for databases and files, and you can use it for Unicode data for different languages. And if you go up a little bit to the left, more and more people are asking about data integrity. can I trust my data? Is it not manipulated? Data lineage. So we talked a little bit about that. And on the far left side, we of course need to comply with regulations. So we touched a little bit on that. But you know, regulations, they are usually simple. No, they are not. But if you have a good baseline, you are almost there. If you have a good security posture, it's a very good chance that you actually can be compliant to most regulations. But we talked a little bit about that. So what did NIST? You can see the acronym at the bottom left. They said, okay, you have a data plane at the bottom. You have a user accessing some resource on the right-hand side. And you have some sort of agent or gateway in the middle that is consulting the control plane at the top. So what is a control plane? That is your policy. So you have a policy engine, you have policy administration. So this is the structure of a zero trust architecture. Let's go a little bit deeper. Where do you do policy enforcement? We talked about it could be a gateway, it could be an agent. So in the middle, you can see the CASB and the SASE. So these are terms that usually are used by Gartner research. So CASB is a cloud access security broker. So what is that? It is, for example, a gateway that is encrypting your data and validating your policy to decide if you should have access to this data or not. And it's also encrypting some sensitive data before it's sent up to the cloud. So what is SASE? It's basically a term coined by Gartner that is a broader way of accessing the cloud resources. So there could be a CASB inside the SASE, but it's basically a framework with different firewall products, CASB, and other things that is controlling your access to the cloud. Very simple, but it's a framework. There are no products. There are no SASE products. Are there? Can you find CASB products? Yeah. There are CASB products that are controlling access control, doing encryption, and so on. So what are they using? If you look on the left-hand side, typically they're using dynamic access control. We talked about that before. Dynamically looking at the context of a request. So it could be ABAC. What is ABAC? It is attribute-based access control. At the bottom, you can see RBAC, MAC, and DAC. So RBAC is different because that is role-based access control. It's just static. You have an access control policy that is static. So what John Kindermark came up with 10 years ago, he said, it's not good enough to have static access control. You need to have this dynamic access control. And we have seen companies delivering ABAC, attributes-based access control, that is looking at the context. Sometimes it's called policy-based access control. So it's a dynamic way of constantly following the user. That's the new world. That's where you want to go. On the right-hand side, you can see you have a request that was denied, you have a request that was granted, depending on, of course, who is the user and their own, what data is the user trying to access. If we want to dig deeper into this zero trust architecture, this is how you can look at it. In the middle, we talked about the gateway. And in the middle, we talk about validating user context. And on the right-hand side, we want to make sure at the top that the user is not the criminal, that the user is actually not stealing credentials and trying to get in. And at the bottom, you can see some examples of system layers. How do I know that I have zero trust? So at the bottom, you can see the reference to US government, CISA.org. And so Jon Kindermark and Forrest, they talked a lot about how do you know that you have zero trust? So we agreed that CISA created a very useful framework. This maturity model can actually look at how do you do identity management, device management, environment analytics, application management, data security. And at the bottom, you can see the maturity levels going from traditional up to optimal for these different areas: identity, device, network, application, and data. And it's broken down into, on the left-hand side, multi-factor authentication. On the right-hand side, cloud data encryption. And in the middle, micro segmentation. So you can see macro segmentation, like network segmentation, was used 10 years ago by many customers that wanted to comply to PCI DSS, payment card industry. And they defined a parameter around their cardholder data. So that's the macro segmentation. So that defined the cardholder data environment, CDE. And then Jon Kindermark came up and said, it cannot be static. You actually need to do micro perimeters. And what is that? That is basically around your data. It's not a network perimeter, network segment. And that's very, very important, and it can be challenging. So it plays into the maturity model. Where are you? Do you have macro? Do you have micro? And how you deal with the data? Do you have static control or do you have dynamic control? So it's a good way to measure how good you are regarding zero trust. So I think we are done with that at a high level. I like use cases. So why? Because use cases show how can I use this in my business? Why should I care? So when we talk about sensitive data, on the left-hand side, you need to care about data generation. On the right-hand side, you need to care about how is data used in applications. And in the middle, you have your applications, you have your analytical systems, you have data sharing. And so we talk about that. Let's start with the use case of data sharing. And usually we talk in terms about multi-party computation. secure multi-party computation. On the left-hand side is the old school model, where we have a central trusted authority that is controlling the access. We're sending the data. On the right-hand side, we have the new model, secure multi-party computation, where we're actually protecting data so before we're sharing it with the different parties. So we don't need a central authority, which is very important. Analytics. So let's say we have analytics in the middle. In the center, we have ML, machine learning. We have AI. We have data science and analytics. And data is coming from the inside, on the left. Data is coming from the outside, from different partners that are sharing data and are doing collaboration. So that data goes into our big data warehouse or data lake. So we talk more about that, what is happening when we take that data from the left, from the right, and start to use it in the middle. So it becomes meaningful for our business. What is secure multi-party computation? It can be very simple, or it can be very complicated. So in this very simple model, at the top we have Jill. She wants to know the average salary, but no one in the group wants to share their salary. So what Jill is doing is actually, she is coming up with a random number that she's adding to her salary. Before sending it to Anton, and then Anton is adding his salary, sending it to Jeffrey, and it all comes back to Jill. So Jill can look at all the sums of the salaries. She doesn't know anyone's salary, but redacting the random number from that sum, she's able to compute an average salary without knowing anyone's salary. And they don't know anyone's salary. And they don't know Jill's salary. So this is a very simple, secure multi-party computation protocol. If we want to make it a little bit more complicated, this is a product in the market that is adding different random numbers and different data owners and analysts and so on. So this is an example of a protocol that is actually used in products. What are use cases that are meaningful for protect the data in analytics? Hybrid cloud is starting to become more and more, I would say, pressing and important. It's something that we use more and more. So on the right-hand side, you have public cloud, you have dedicated private clouds. On the left-hand side, you have, of course, on-prem systems, and you have your local clouds. So we need to consider this configuration, this environment to live in. So a use case from a bank, they had data coming in from different databases and data sources. And the machine learning tool calculated that they had a privacy risk of 26%. So these different tools can calculate your privacy risk. And you can tune different parameters, but they basically say, okay, your privacy risk is 26% for this data. So they wanted to still have good data quality, but they wanted a lower privacy risk. So by using these techniques that we will talk about here, they took the privacy risk down from 26% to 8%. And they still had almost 100% data quality. So the tool calculated that they had 98% accuracy. So this bank said, okay, we reduced the risk and we're comfortable with that reduction. And we still had 98% data quality. And then they said, okay, it's good enough for our machine learning. So what is the magic here? They applied anonymization. They used differential privacy and k-anonymity. And those are just protocols that are adding some noise to the data for reducing the risk of identifying individuals. They had that for most of the sensitive attributes, different type of attributes on your data. It could be all kind of different attributes in the database. And they applied pseudonymization to identifiers. Those are typically for identifiers that social security numbers and so. And they applied encryption or tokenization to these identifiers. So in the middle, you see a couple of examples where they pulled the data from credit card statements, operations, household employment data. So they protected that going in with ETL, loading tools to databases, and they applied security processing that we talked about above before the data went into different storage. Amazon S3 buckets for files, Amazon Redshift, Databricks, Spark for machine learning data sets. And then it went in at the bottom right to machine learning model building. So eventually it ended up in Amazon SageMaker, where you can build your machine learning models and you use those models. So this is a very powerful way to reduce risk and still have a good outcome in your machine learning and analytics. So how much data did you actually protect? At the top, you tokenized, encrypted some identifiers with typically tokenization because it's very powerful. A small fraction of the data. At the bottom, most of the data was actually kept in clear text. In the middle, we talked about attributes. You used, you can see on the bottom left, differential privacy and k-anonymity on a lot of the data to add noise to the data. And the gray one, synthetic data, some of the data couldn't really be protected in a good way. So they decided to replace that data with fake data, or, well, synthetic data. Data that is actually giving a good data quality in analytics, but it's not something that is coming from your business data necessarily. Sometimes yes, sometimes no. But it's lowering your compliance burden. So it's a good mix. You can play with the different tool sets here, or different techniques, and get a balance between your privacy and your utility. How much business quality do you need to get out of the protected data? So when we look at data analytics, different use cases, where do you use it? On the left-hand side, you do it before you go to cloud. On the right-hand side, you may want to actually protect some data before you go to the data lake, because you don't want to put a lot of sensitive data in the data lake. It's a liability if you put a lot of regulated data in the data lake and you're not aware of it. And then in the middle, you have a machine learning. We talked about that, and different type of use cases. So these are typical use cases for data analytics. Is this important for healthcare? Yeah, at the top you can see what they want to look for. They want to track patient information, prescriptions and refills. At the bottom, for financial services, we talked about that a little bit. There are different use cases. At the bottom, you can see for financial services. Is it useful? Yeah, it works, and this is what organizations are using. What is fake data or synthetic data? People are a little bit scared about synthetic data. They don't know. Where does it come from? So let's talk about that. Is Gartner interested in synthetic data? Well, not in 2021, but suddenly in 2022, Gartner said, oh, this is very important. It's up there at the top of the hype cycle. So suddenly Gartner said, this is something. And people are starting to use it. The color coding at the top right, you can see cloud AI labeling for different data. You can see there on the left-hand side, differential privacy. You can see different type of, look at the green in the middle, format preserving encryption, data classification. So you can see different types of tagging for different types of techniques in the Gartner hype cycle. What is Gartner saying about synthetic data? They're saying that we will be using real data more and more. But if you look a few years down the road, Gartner is saying that synthetic data will be like a hockey stick. So around 2025, Gartner is saying that, oh, it will take off. Most of our data will be synthetic data. So it's interesting. What is synthetic data? We talked a little bit about it, but on the left-hand side, you have your original business data. In the middle, you have at the top fully fake data. It's just generated, fake data. At the bottom, you have derived data. So it's derived from your original data. So Gartner is calling it partially synthetic data. On the right-hand side, why are we doing this? It's because we want to reduce cost, increase privacy. It can be applied for structured and unstructured data. And then people are concerned about limitations. What will the data quality be? And I hear a lot of questions about black box generation. And they're basically asking, I don't understand how this data was generated. And it's a little bit similar to explainability in machine learning. People ask, why did this answer come out at the end? I want to understand. So that is improving in machine learning. And similar in synthetic data, it's a big question mark. It's not solved. Black box generation. Some companies are trying to solve it. So, for example, Strategist, they are calculating an assurance report. So they look at the synthetic data, compare it to the real data, and they generate a report that is showing what actually happened. But it's kind of evolving, and there are many question marks right now. Examples. So if you compare original data with synthetic data for different types of data, they can be a little bit different. You can see the different percentages here. So data lakes. What is the data lake? We talked about that. And we said, okay, you take data into a data warehouse, into database tables. So you need to structure the data. When you do some, you get an understanding of the data, what types of data you have. When it comes to data lake, it's more like you just shuffle into data. You don't know what you have. And one day you go back and use the data, analyze the data. Yeah, at the right-hand side here, you go into the data processing and consumptions when you start to use the data. But on the left, when you gather the data, you don't know what you have. So what is a data fabric? It is a combination. You combine the data warehouse at the middle, at the top. You combine that with the data lake at the bottom middle. So you create the data fabric. And you start to link data and enrich the data, you catalog the data, so you know what you have. So it's advancing your different type of data from the left into something you can actually understand and use. To make it a little bit more complicated, you can define this data lake reference architecture, where you get different sources on the left-hand side. Your databases and unstructured data, your emails and what you have. And then you push it into the middle, where we do the processing, consumptions, and so on. At the end, on the right-hand side, you can start to actually do some business intelligence, and you can use it in applications and portals. So it's a way to look at it in a production, I would say production scenario. Sometimes we hear that organizations are moving to cloud. Is that true? No. So what IDC showed us is that organizations are not moving to cloud. They are increasing on-prem at the same speed as increasing in cloud. So it's, yeah, they are typically adding new functions in cloud, but they're still growing on-prem. So what is that telling me? We still have a growing on-prem environment. At the same time, we are increasing different cloud platforms. So it's getting complicated. From a security point of view, we need to have an umbrella covering these different multi-cloud environments. And we need to have this hybrid security model that is also covering the increasing on-prem. So it's not getting easier. So there's no solution that we just move to cloud and it's gone. The problem is gone, security problem is gone. It's just getting complicated. So we need to plan for that. So what is this? This is data from US Federal Trade Commission and IDC and corporation analysts, and from PricewaterhouseCoopers. So what they are saying, at the top, the gray one is showing that over a couple of years, the identity threats are just going up, 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 up. And I think it's concerning. At the bottom, PricewaterhouseCoopers are saying that still only 80% of the data is protected. And they say protected by baseline security. It's not very protected, it's just baseline security. So 80% is just protected. And IDC in the middle, International Data Corporation, are showing that, not surprisingly, there will be more and more data around. And when I look at this picture, I'm just saying that, I think we have a problem, growing problem on hand. Sometimes we hear that phishing is the problem we need to answer. Well, it's good to have some user education and so, but we know that the supply chain, the software bill of material, is adding to this picture. Malware is coming from below. No user interaction, it's just coming in. And if you look at the top, it only takes one user issue to introduce malware. On the right-hand side, you can see the malware is hitting different layers, system layers. And more, these malware are hitting our data, sensitive data. It could be different type of ransomware, stealing your data, or destroying your data, encrypting your data. So what should we do? I think we should look at the data. Go to the right and see, okay, I have sensitive data. How should I protect that data? And on the left-hand side, yeah, the attacks can come from all kind of directions, and it will change every week or every year. But on the right-hand side, they're going after my data. So what can I do strategically to protect my data? That's my core message here. On the left-hand side, we have the corporate environment with different data sources and so on. And of course, we have the cloud providers in the middle. On the right-hand side, we have seen more and more users having their home offices and mobile devices where they download sensitive data. And of course, we cannot control what is happening in this shallow IT on the right-hand side. In most cases, we cannot control what's happening on users' private environments. Some have corporate devices and so, but not always. And in the middle, we may have some knowledge about what's happening with Amazon and Google and so on. But now we don't really know what the administrators are accessing in those environments. So on the left-hand side, I'm basically saying that, okay, we have sensitive data. And before that data travels to different other environments, at least we can protect that data. We can encrypt some data feeds before sending it over to the right. So that's, I think it's a very powerful and minimal way we can start. If we encrypt data, where are the encryption keys? Okay, so Amazon is saying on the left-hand side, you can do your key administration and manage your encryption keys. That sounds good. But then on the right-hand side, Amazon is saying, well, I actually want your encryption keys here to be able to decrypt data, encrypt data. Okay, so the key is gone. That's pretty scary, but it's okay. They want my key. Okay, it's not stored fully in their environment, but you never know. Okay, it's stored in my environment, and they can say to government or to anyone, okay, we don't have the key. We just get the key for a moment when we need to decrypt and encrypt. So, okay, it's a kind of a middle ground. So what is the hold your own key? You can see on the left-hand side at the bottom, hold your own key means that, okay, I will not give my key away. You can see in the middle, I have a piece of software that is protecting my key. I don't give my key to Amazon, AWS. I keep the key, I encrypt and decrypt, and they never see my key. Oh, that's good. That's pretty good. And I can do encryption and decryption in the cloud. So that's great. And I still have control on the left-hand side on the key management. So it's a pretty powerful model. This is like, we will compare these. So the model we talked about here, if you go down to the left, you can see hold your own key. Where do you have that in the risk and control matrix here? So on the left top, you have hold your own key. You can have it in the agent. That's the one we looked at before. Or you can have it in the CASB. That's the one we talked about earlier, an encryption gateway. So those will keep your key inside. They're not sharing the key with anyone. They protect your key. So what does that mean? On the left-hand side, you can see how much control do you have, client control of data. It's high because you do not give the key away to anyone. On the far right, of course, you can ask Amazon AWS to do your key management. But you have no control. You don't know what they do. It's convenient and they can do it for you. And in the middle, there's some gray zones where you know, they can say, oh, we have a hardware security module, HSM, that can give you some protection. There can be client-side management with the client-side encryption in the middle. But I don't know where the key is. The key is gone. The key is shared. So that is the story about bring your own key. So if you go down to the left, bring your own key. As we started to talk about, yeah, you manage the key, but you send it away. Off it goes. You never see the key again, and you don't know where the key ends up. So what is your risk appetite? Well, for some data, I don't care. I want the convenience. And for some data, I care. So I want to have very high client controller data. If you look at the left side here, some data, I care. The rest, I don't care about. But don't let anyone talk you into what they try you to do. We talked about different techniques for data security. We talked about encryption. We talked about homomorphic. We talked about tokenization. On the right-hand side, we talked about differential privacy and k-anonymity. So we also said that, okay, on the right-hand side, you use these techniques for attributes. You add noise to attributes. For example, you have synthetic data. We talked about derivation of data on the right-hand side. On the left-hand side, you have two-way encryption, where you actually can get the data back. You can decrypt, you can detokenize, and it's typically used for what you know, GDPR is typically referring to pseudonymization, and usually for identifiers. To replace a social security number or a credit card number with a token or some type of encrypted data. At the bottom, you can see it can be used for data in transit, in use, and at rest. Some are fast, some are slow. Is tokenization different? Yeah, it comes in different flavors. So tokenization can be impacting your latency, performance, and footprint. So on the left-hand side, you can see different styles of tokenization: vaultless, vault-based, dynamic, vault-based pre-generated. Pre-generated is maybe not that practical because you need to boil the ocean and generate all kind of versions. So I think vaultless at the top and the vault-based on the left are the more practical ones. But there are considerations about performance, collisions, and other things that I think are good questions. Before you decide, you should know your use case. Do I need speed? What is the use case? Is replication an issue? So you need to ask these questions before you decide what type of tokenization you want. And you need to look at what data. Do I have unstructured data, structured data? Is the data flow very simple, like in payment card systems? Or is it very complex, like in many health systems? So here you can see kind of a map where I think the bottom line here is that you can say, okay, a number is a number. It could be a payment card number, could be a PII, social security number or something. So can I, that's very structured data. So can I tokenize? Yeah. Can I use format preserving encryption? Yeah. This is an example of one way to lay out a roadmap. So on the left-hand side, what issues do I want to address? Speed, data ownership, data sharing, quantum attacks, data integrity and manipulation, user attacks, data leakage. So at the bottom, you can see an example of laying out different approaches for data security, zero trust, data provenance, quantum, smart contracts, data distribution, and so on. And in the middle, you can see kind of a layout, an example of how could you map this out. Maybe you start with the data protection, basic data protection, data security. And then you may add a zero trust in the middle. So what should I do with zero trust? So Gartner is saying that, okay, 5 simple steps you can do to get zero trust started. Multi-factor authentication, MFI. Replace your VPNs. Encrypt all data at rest in cloud. Remove admin rights from most users. And segment critical applications. So this is what Gartner is saying, that, okay, the 5 first steps is probably what you want to do here. But I want to go back to Amazon AWS. If you encrypt your data, you need to know where your encryption keys are. Otherwise, you don't know what control you have. Same again. Do you want to hold your own keys instead of letting the key just flow over to the cloud? And going back to the risk profile, how much risk do I want? And it's different for different data. So sometimes I want to be very secure. So I go left and up. And sometimes I don't care. I want to have the convenience. So I go right. And if I want to have something in the middle, I do something with HSM, hardware security modules, or client-side encryption, to kind of have a better posture, I would say, a little bit better posture. I get a lot of questions about different standards and guidelines. So if we look on the left-hand side, you have different standards. US National standards, financial industry standards, application and encryption standards, international standards, European standards, US healthcare, and user groups. So these are on the left-hand side. And in the middle, you can see how different regions are rating this. Just an example. So US, they give a high rating, most important, on a couple of the top ones here. Europe, EMEA, they have a little bit different rating. And APAC, they are, I would say, very different. On the right-hand side, you can see basically what these are dealing with. Some are zero trust, some are encryption keys, some are access control, and others are payment card industry standards, and it goes down here. And on the right-hand side, far right, you can see examples of alignment. So what did they do, actually, these organizations? In the middle, you can see PKCS 5. PKCS 5 is password-based encryption. PKCS 11, it's an interface to hardware security modules. PKCS 12 in the middle on the right-hand side is how you deal with certificates, like different type of certificates for keys. For example, maybe I shouldn't mention all of them, but it could be ECC, elliptic curve cryptography certificates, or it could be RSA certificates. So this is an example where an organization said, okay, we have more than a handful of different standards, guidance on the left-hand side. And this is how we will focus and rate these different alignments. So we know that, okay, these are important, and this is what we actually do to align. I think this is important to understand the landscape for different techniques, because they can look alike, different data protection techniques, but they can have very different consequences on your organization. And this is important because tokenization came in different flavors. And this is the general map that we talked about for different type of data. This is where you typically use the different techniques for different types of data. Create a roadmap so you know that this is actually what we care about. What issues do we want to address on the left-hand side? And what are the techniques at the bottom that are typically applicable for these different issues? Then I get a lot of questions about quantum attacks. Do I need to care? A lot of work is already done by IBM and MIT and D-Wave, for example. On the right-hand side, you can see Gartner is saying that will RSA algorithm be cracked? It will take a couple of years. I mean, the whole internet is based on RSA algorithm, TLS, the earlier SSL. So yeah, eventually those keys and the data, associated data, will be cracked, no longer secure. Will it be meaningful for businesses? Quantum, it will take some time. And quantum cryptography. When should I start to care? Yeah, you should start to plan now, because changing your algorithms, changing your RSA protocols, products, will take time, many years. So you need to start planning now. I talk much more in my book about this. And you guys, you have a discount that I think will be shared with you, where you basically get, I think it's 20% discount on my book. And it's available. And you can see the different chapters here where I talk about, the book is about 400 pages, 350 maybe. And I talk about different machine learning, analytics, blockchain, hybrid cloud, and other items in these different chapters. So on the right hand side, you can see the link where you can access the book, and you have my email address on the right also. It's been a pleasure to be with you, and I hope the force will be with you, the data privacy force.
Thanks a lot, Ulf. We don't have any questions just yet, but I've put the link to the book in the chat so they can click on there.
That's wonderful, Ulf. Thank you so much. Hey, are you still there? Not you,
Yeah.
not Ulf, but the audience, because I don't know about you, I'm still struggling. I'm about 20 slides behind, and there are questions coming in. Will the recording be shared and so on? We certainly hope so, but I should say that in a few days' time, we'll know if the recording is good enough to share. We'll verify that with Ulf, and then we'll share it. But I thought that was absolutely fascinating. I won't pretend to understand more than about 20% of it, but the book is there for us to look through and learn more. And boy, what a fascinating subject. I certainly hope you make the most of it and benefit from the book and the offer. So Ulf, thank you so much. This is getting to be a regular thing. So we look forward to seeing you next time. And we look forward also, hopefully, to seeing you in London. Now, also, the other thing I should say to everyone is that we are working out webinars at the rate of almost one per week at the moment. You probably know that on the 26th of October, we have our next one, which is called 11 Pragmatic Tips for Implementing New Emerging Technology. I should warn you, it's a whole different level to Ulf's in-depth technical talk, but it will be just as fascinating. And then the next one after that will be Humanizing Technology, Regaining Trust.
Tell them you're on mute.
For both of those, the 11 Pragmatic Tips is on 26th of October. It's a webinar in the evening. And the Humanizing Technology is on the 1st of November, and that is hybrid. So you can come along to BCS London, or you can see it as a webinar. And that's by Mike Lloyd. Anyway, look forward to seeing you 26th of October, 1st of November, and Ulf, look forward to seeing you the next time you're in London. All the best, everybody. Thanks for joining us tonight. Look forward to seeing you next time. Bye for now.
Bye.
Thank you.